to the pre-class video on the equilibrium quotient and calculating delta G at non-standard conditions. So you're going to be introduced to this idea of the equilibrium quotient. It has a symbol of Q for quotient.
Right.
And it's a little confusing because it looks exactly the same as an equilibrium constant.
What's different about it?
What is different about it? Well, what's different about it is that the equilibrium constant describes the reaction at equilibrium.
Right.
So if you're going to say K equals concentrations, they have to be equilibrium concentrations. Q is used at any other conditions of concentration or pressure.
Okay.
So when you first put stuff in a flask, that's Q. You put the concentrations into the equilibrium expression, what you calculate isn't going to equal K, right? Because it's not at equilibrium yet. It's going to equal Q. So it's kind of an idea that we develop in the first half of the activity, or the first activity. The second part is about calculating non-standard delta G's.
So yes, this is the truth.
It is. And non-standard conditions. And you might be asking, well, why are we going back to delta G? That's thermodynamics. Well, thermodynamics and equilibrium, it's all one thing. It's all chemistry. Right? And remember back to thermodynamics, we figured out how to calculate delta G at non-standard temperatures. Delta G equals delta H minus T delta S. Put in a non-standard temperature, you can calculate delta G at that temperature. But there are also non-standard conditions of concentration. Well, this doesn't have concentrations as a variable in it, so we can't use that. And so what we're going to use is a different equation. Delta G equals delta G naught plus RT natural log of Q. And these Q's are the concentration at whatever conditions exist when you ask the question.
Right.
The cool thing about this is that by the end of the activity, this is going to morph into K. It's going to tell us how delta G is related to K.
Ooh.
And that's really kind of a cool thing, kind of powerful.
So we're not going to tell you yet.
Nope.
Save the mystery.
Exactly.
Yes.
Something exciting for class.
Ooh.
Okay? So I just wanted to introduce you to the ideas and tell you a little bit about what our goal is going to be. And so we'll see you in class.